It is understandable to be dissatisfied with the performance of newly purchased exit and emergency lights. However, not naming the manufacturer does make it difficult to provide specific guidance or assess whether others have encountered similar issues. Generally, it is recommended to provide the name of the manufacturer when seeking feedback or opinions about a product because it allows for targeted discussions and potential resolution of concerns. Here are some general issues with exit and emergency lighting systems. Grounding is a critical safety feature in electrical systems, including exit and emergency lights. A ground screw provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Firstly, ensure the ground screw is properly sized and compatible with the enclosure material. A sheet metal screw thread may not provide sufficient contact and conductivity for a reliable ground connection. Secondly, if the provided ground screw is inadequate, use a tap to create appropriate threads for a properly sized ground screw. A common size for grounding screws is 10.32. Thirdly, ensure that the grounding conductor is securely attached to the ground screw in the enclosure. Use a star washer to improve the connection and prevent loosening. Mounting brackets for exit and emergency lights must be securely attached to the building structure. The brackets should be designed to support the weight of the light fixture and withstand vibration or impact. When installing mounting brackets, consider these points. Firstly, check for obstructions such as electrical boxes, pipes, or structural members behind the mounting surface. Adjust the bracket position to avoid these obstructions. Secondly, use appropriate fasteners for the mounting surface material. For drywall or plaster, use wall anchors or toggle bolts. For concrete or masonry, use concrete screws or anchors. Thirdly, ensure that the mounting screws are long enough to penetrate the mounting surface and engage securely. Use shims to level the bracket if necessary. LED failures in exit and emergency lights can be caused by several factors. Firstly, check the LED driver for proper voltage and current output. A faulty driver can cause LED to fail prematurely. Secondly, inspect the LED modules for damage or discoloration. Overheating or physical stress can damage LED. Thirdly, ensure that the LED modules are properly cooled. Adequate heat sinking is essential for LED longevity. If only half of the LED light up, it suggests either a driver issue affecting one channel or a problem with the LED module itself. Check the voltage to the module and inspect the module for damage. Battery backup systems in emergency lights provide illumination during power outages. Battery problems can arise from several sources. Firstly, check the battery voltage and capacity. A fully charged battery should provide the rated voltage for the specified duration. Secondly, inspect the battery terminals for corrosion or damage. Clean the terminals with a wire brush and apply a corrosion inhibitor. Thirdly, replace the battery if it is old or shows signs of degradation. Most emergency light batteries have a lifespan of 3 to 5 years. If the battery backed up side doesn't light up, it could indicate a dead battery, a faulty charger, or a problem with the switching circuit that activates the backup power. Test buttons on emergency lights simulate a power outage to verify that the battery backup system is functioning correctly. Test button failures may be due to these possible causes. Firstly, check the test switch for continuity. A faulty switch may not activate the backup system. Secondly, inspect the wiring between the test switch, the battery, and the lamp. A loose or broken wire can prevent the test from working. Thirdly, check the battery voltage under load. A weak battery may not be able to power the lamp during a test. If the unit doesn't operate when pressing the test button, it suggests a problem with the test circuitry, the battery connection, or the battery itself. Verify the battery voltage and the connection to the test switch. Quality control issues can arise during the manufacturing process. These issues can include design flaws, substandard materials, or inadequate testing. Possible problems with this include incorrect components, poor soldering, or improper assembly. If you encounter widespread quality control issues with a product, here are a few courses of action. Firstly, document the issues with photos, videos, and detailed descriptions. This will provide evidence for your complaint. Secondly, contact the supplier or manufacturer to report the issues. Provide them with the documentation you have gathered. Thirdly, request a replacement, refund, or other resolution. Be prepared to negotiate and escalate the issue if necessary. When contacting the supplier or manufacturer, be professional and courteous but firm in your expectations. Clearly state the issues you have encountered and the resolution you are seeking. Provide them with all relevant information such as the product model number, date of purchase, and a description of the problems. Follow up with them regularly to ensure that your complaint is being addressed. Consider writing a formal letter detailing your concerns and requesting a response. This can help to escalate the issue and ensure that it is taken seriously. When installing electrical equipment, it is important to follow all applicable codes and standards such as the National Electrical Code (NEC). The NEC provides guidelines for safe and proper installation practices. Some key NEC requirements for exit and emergency lights include proper wiring methods, grounding, overcurrent protection, and emergency power systems. For example, NEC Section 700.12 addresses emergency systems and specifies the requirements for the source of power, transfer equipment, and wiring. NEC Section 700.16 covers emergency lighting and power requirements, including illumination levels and duration. NEC Section 701 addresses legally required standby systems which provide power to critical loads such as exit lighting during a power outage. Article 700.4 covers capacity and rating, stating that the emergency system must have adequate capacity and rating for all required emergency loads. NEC Section 700.9b specifies that wiring for emergency circuits must be kept independent of other wiring. NEC Section 700.12 describes various acceptable power sources for emergency systems, including storage batteries, generators, and uninterruptible power supplies. NEC Section 700.26 requires periodic testing of emergency systems to ensure their proper operation. Firstly, monthly testing involves activating the emergency lighting for a short duration, typically 30 seconds, to verify that the system is functioning. Secondly, annual testing requires a longer duration test, usually 1.5 hours, to ensure that the battery can sustain the emergency lighting for the required time. NEC Section 701.11g requires that standby system wiring be mechanically protected. NEC Section 700.27 specifies that emergency lighting must be arranged to provide initial illumination that is no less than an average of 1 foot candle and a minimum at any point of 0.1 foot candle measured along the path of egress at floor level. Maintaining accurate records of inspections, testing, and maintenance is crucial for demonstrating compliance and ensuring the ongoing reliability of emergency lighting systems. Firstly, keep a logbook or electronic record of all inspections, tests, and maintenance activities performed in the emergency lighting system. Secondly, record the date, time, and results of each test or inspection, as well as any corrective actions taken. Thirdly, retain all documentation related to the emergency lighting system, including product manuals, wiring diagrams, and inspection reports. When dealing with electrical installations, it is essential to prioritize safety. Always to energize circuits before working on them. Use appropriate personal protective equipment, PPE, such as gloves, eye protection, and insulated tools. If you are not comfortable working with electricity, hire a qualified electrician. Consider the location in southern New Hampshire. The climate may affect outdoor lighting. Also, always follow local electrical codes. When handling defective products, it's crucial to follow proper procedures for returns and documentation. Firstly, carefully package the defective items to prevent further damage during transit. Secondly, include all original packaging, manuals, and accessories. Thirdly, clearly label the package as defective or returned for credit. When returning items to the supplier, obtain a Return Authorization Number, RAW, or Return Merchandise Authorization, RMA, number. This will help to track the return and ensure proper credit. Include a copy of the original invoice or packing slip with the return. Ship the package using a reputable carrier and obtain a tracking number. Keep a record of all communication with the supplier regarding the return. When dealing with LED lighting, consider the color temperature and light output. Color temperature is measured in Kelvin, and it affects the appearance of the light. Lower Kelvin temperatures, such as 2700 Kelvin to 3000 Kelvin, produce a warm, yellowish light. Higher Kelvin temperatures, such as 4000 Kelvin to 5000 Kelvin, produce a cool, white light. Light output is measured in lumens, and it indicates the brightness of the light. Choose LED lighting with appropriate color temperature and light output for the application. When troubleshooting electrical circuits, use a multimeter to measure voltage, current, and resistance. A multimeter can help to identify open circuits, short circuits, and other problems. Firstly, set the multimeter to the appropriate range. Secondly, connect the test leads to the circuit. Thirdly, read the measurement on the display. When measuring voltage, connect the test leads in parallel with the circuit. When measuring current, connect the test leads in series with the circuit. When measuring resistance, de-energize the circuit and connect the test leads across the resistor. When installing electrical boxes, ensure that they are properly sized and supported. The size of the box depends on the number and size of the conductors that will be installed in it. The box must be securely attached to the building structure. Use appropriate fasteners for the mounting surface material. When running conductors through electrical boxes, use cable clamps or connectors to protect the conductors from damage. Leave sufficient slack in the conductors to allow for easy connections. When making wire connections, use wire connectors that are rated for the size and type of conductors being used. Twist the conductors together tightly before applying the wire connector. Ensure that the wire connector is securely tightened. When working with battery backup systems, be aware of the potential hazards associated with batteries. Batteries can contain corrosive chemicals and can produce explosive gases. Firstly, wear appropriate personal protective equipment, PPE, such as gloves and eye protection. Secondly, avoid short-circuiting the battery terminals. Thirdly, provide adequate ventilation when charging batteries. Dispose of batteries properly in accordance with local regulations. When dealing with emergency lighting systems, it is important to consider the needs of people with disabilities. Ensure that the lighting is adequate for people with visual impairment. Consider using emergency lighting that provides both audible and visual signals. Ensure that the emergency lighting is accessible to people with mobility impairments. When selecting emergency lighting equipment, choose products that are listed and labeled by recognized testing laboratory such as Underwriters Laboratories, UL, or Intertech. Listed and labeled products have been tested to meet safety standards. Look for the UL or Intertech mark on the product. When installing emergency lighting systems, follow the manufacturer's instructions carefully. The manufacturer's instructions provide detailed information about installation, operation, and maintenance. Failure to follow the manufacturer's instructions can result in improper operation or safety hazards. When performing maintenance on emergency lighting systems, keep accurate records of all work performed. This will help to track the maintenance history of the system and identify any recurring problems. Record the date, time, and description of the work performed, as well as any parts replaced. When troubleshooting emergency lighting systems, start by checking the power supply. Ensure that the system is receiving power from the normal source and the emergency source. Check the circuit breakers and fuses to ensure that they are not tripped or blown. Use a multimeter to measure the voltage at various points in the circuit. When replacing components in emergency lighting systems, use only approved replacement parts. Using unauthorized replacement parts can void the warranty and create safety hazards. Contact the manufacturer or supplier to obtain approved replacement parts. When upgrading emergency lighting systems, consider using LED technology. LED lighting is more energy efficient and has a longer lifespan than traditional lighting. LED emergency lights are also available with battery backup systems. When designing emergency lighting systems, consider the layout of the building and the paths of egress. The emergency lighting should provide adequate illumination along all paths of egress. The lighting should be arranged to avoid creating shadows or glare. When installing emergency lighting systems in hazardous locations, use explosion-proof fixtures. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Explosion-proof fixtures are designed to contain any explosion that may occur inside the fixture. When installing emergency lighting systems in wet locations, use waterproof fixtures. Wet locations are areas where water may be present. Waterproof fixtures are designed to prevent water from entering the fixture. When selecting emergency lighting systems, consider the aesthetic appearance of the fixtures. The fixtures should be compatible with the architectural style of the building. The fixtures should be unobtrusive and blend in with the surroundings. When installing emergency lighting systems, ensure that the fixtures are properly aimed. The light should be directed towards the paths of egress. The light should not be directed towards occupants' eyes. When performing inspections of emergency lighting systems, check for any signs of damage or deterioration. Inspect the fixtures, wiring, and batteries. Replace any damaged or deteriorated components. When testing emergency lighting systems, simulate a power outage to verify that the system is functioning correctly. Disconnect the normal power supply to the system. Observe the emergency lights to ensure that they illuminate properly. When dealing with emergency lighting systems, it is important to be aware of the potential for liability. If someone is injured due to a malfunctioning emergency lighting system, the owner or operator of the building may be liable. Ensure that the emergency lighting system is properly installed, maintained, and tested.